So, in the last class we were discussing the stable and monostable multivibrator using the Schmidt trigger. Then this was incorporated into a chip which I mentioned to you as 555, and let us see the inside structure of this 555.
There will be a minus, sir. In that there will be a minus at the bottom. You put a minus at the bottom. But then you didn't connect it. Yes, that connection was. That connection was to the triggers.
Yeah, let me check.
Positive connection was to the threshold.
This goes to plus.
Yes, sir.
This is the circuit for the 555 inside circuit. These are the three terminals available, and these are the two terminals here. One is internally connected, this is called the output terminal. So let us see how this operates as a monostable. Timer, one shot, equivalent names. Now you connect a capacitor and a resistor to VCC, external to this. Then you take the connected terminal, capacitor terminal, and this voltage is so-called threshold voltage going to an E555. to the threshold terminal. And then this discharge is also connected here. This is again coming from NE555, the same terminal. So, external to this, now the circuit is somewhat complete by connecting this some terminal to some appropriate network outside world. And then let us see how it functions as a monostable. Initially, Q and Q bar, which are dual to each other, Q bar is 1 and Q is 0. We will have to justify that, but let us assume this is 0 and this is 1. If this is 1, then 1 means some plus positive, some voltage, positive voltage. So, this PNP transistor, NPN transistor will be saturated, because this voltage through this resistance will provide enough current into the base. So, that collector current is very large. So, that the voltage across the transistor will become very small. So, this is saturated condition. Once in saturated condition, the discharge terminal will be at almost ground potential. So, this capacitor initially sits at ground potential, okay, because of the configuration of this being 0 and that being 1. Now, the same 0 is sitting at the threshold terminal, right? Now, this threshold terminal is going here at the plus, and this voltage is 2/3 voltage VCC, whatever is the voltage connected here VCC. So, this is sitting at 2/3 VCC and this is sitting at 0. So, this comparator will be sitting at low, right? This will be sitting at 0 initially. And look at the second one. Second one is initially set so that this is sitting at VCC. This is another external terminal. Initially it is set VCC. When this is VCC and this is 2/3 VCC, then what will happen to this terminal here? Output will also be 0. So, R is sitting at 0 and S is sitting at 0 and the trigger is sitting at 1 or plus high level. Is this initial condition agreeable?
Excuse me, sir. They are saying that since the last time you didn't draw this picture, so now they don't know which one is R and which one is S, sir. You have to mark it, R and S. They don't know which one is R and S because you didn't draw this picture last time.
R and this is this. I am sorry. I thought I would draw it.
I didn't get how R and S is 0. I didn't get how R and S is 0.
Initially, I have to justify that this is the initial condition of all the terminals on the NE555 along with the external connection, right. I am starting with Q and Q bar being equal to 0 and 1, and I will justify that all other terminals are at what are mentioned here. And logic state for this RS flip-flop must be also same as this. We will check that. That means, if RS is 0, 0, then Q and Q bar must be at 0 and 1. That is what the flip-flop characteristics are, RS flip-flop characteristic. If RS is sitting at 0, 0, the output will be Q will be 0 and Q bar will be 1. And for some other RS change, the binary one, 4 possibilities. For these 4 possibilities, the appropriate values of Q and Q bar. That we'll write down that later on. But question that I am asking initially, where is this sitting? I am assuming that initially it is sitting at 0 and 1 If that is the case, this 1 makes this transistor saturated, because a positive voltage is applied to this base of this through a resistor. So, the base current is high enough to saturate the transistor. So, as a result of that, from collector to emitter, this is almost a short circuit. So, if this is a short circuit, the discharge terminal which is connected across the capacitor make the voltage across the capacitor 0. The same terminal is going to threshold terminal. So, threshold is sitting at 0. Now, look at this circuit. If threshold is sitting at 0 and this is connected to 2/3 VCC, this must sit at 0, because this is sitting at a higher voltage compared to this. So, this sits at 0, all terminals sit at 0. Now, let us look at this terminal. This terminal trigger is at high, this is VCC level. So, this is sitting at high and this is sitting at 1/3. So, this will also be 0. So, you have a logic here, truth table, RS is 0, 0 and 0, Q and Q bar. So, this is perfectly justified for RS flip flop. If RS is 0, this is the flip flop. If RS is 1 is not allowed,